Hello students, welcome back. Let us resume our discussion in section 1. We completed discussing the radian angle, and if you went through the digression as well, then you'll have much better motivation for using radian measure, not the degree measure from this point on. Even if you skipped it, still do not use degree anymore. Not until lesson 15, where we come back to geometry. Alright, now let us define trigonometric functions. No more trigonometric ratios based upon static constant angle, but let us now define trigonometric functions for the variable theta. As usual, we begin with a bit of a geometry. A circle centered at the origin with radius r. In that case, we have horizontal squared plus vertical squared is hypotenuse squared. But hypotenuse is the radius, so we end up with x squared plus y squared is equal to r squared. We have a typical picture here, but that's randomized, so you can run it again and get something different. Not too different this time. Yeah, very different this time. Well, all right. Whatever quadrant, you can always inscribe a right triangle, the angle at the origin, and right angle at the x-axis. Alright, now that we have the circle, we define the trigonometric functions, not the ratios. Sorry about that. Sine of theta, cosine of theta, tangent of theta are defined as y over r, x over r, and y over x respectively. And x and y are coordinate axes. They can be either positive or negative depending upon the position of this point, x comma y. And r, the radius, is the distance, the radial distance from the origin to the point on the circle. So it's always positive and it stays always the same. And then cosecant, secant, and cotangent are defined as their reciprocals. R over y, r over x, and x over y. So we covered all trigonometric functions. Well, there are three quantities, x, y, and r, and then ratio of 2 in any order. Yeah, there are total 6, and we covered all 6. But the latter three, cosecant, secant, cotangent, are not very important. They are reciprocals of sine, cosine, and tangent, respectively. So focus upon the standard 3. And then what are their signs? It depends upon the signs of x and y. R is always positive, remember. So x is in this picture, in this case, second quadrant, x is negative, y is positive. So cosine is negative, sine is positive, tangent is negative. You can get all those from the second quadrant. And then run this program again, and then go to the third quadrant, all right? Then what do we have here? Both x and y negative, going to the left, going down. R is always positive. So sine y over r is negative. Cosine x over r is negative. Tangent y of x is positive. Negative or negative, so that's positive. And so on and so forth. Extend this logic for all quadrants, and you're going to end up with this conclusion. A smart trig class. So, all positive in first quadrant. Sine is positive in second quadrant. The other two, cosine and tangent, are negative. In the third quadrant, tangent is positive, the other two are negative, and finally in quadrant 4, cosine is positive, the others are negative. So, a smart trig class must remember all those. Okay, alright, so much for the trigonometric functions. Now, let's do some example problems associated to that. Determine the values of sine, cosine, tangent, and so on. Everything under the given condition, one trig value and the sine of the other. One trig value and a quadrant would suffice actually, but we can deduce the quadrant by the sine of another trig value. So cosine is 5/7 positive, tangent is negative. What is this quadrant? Cosine is positive, tangent is negative, a smart trig class. What is it? It is fourth quadrant. See that? Cosine is positive, tangent is negative, a smart trig class. Yeah, cosine is positive, so here it belongs to class. So it's fourth quadrant. So you can draw a triangle on the fourth quadrant. And then it's 5/7. You don't have to draw it perfectly. Just get the angle at the origin, right angle at the x-axis. That's going to be sufficient. 5/7. So horizontal over radius is 5/7, or adjacent or hypotenuse 5/7, and we don't know the opposite. Well, we can figure it out through Pythagorean. So hypotenuse squared minus this one squared. Using the Pythagorean formula, we can find out the length, and it is square root of 24, and I can write it here. Or if you prefer to get the coordinate axis, you can get y is negative square root of 24. Either way it works out. Me personally, I prefer the picture and labeling it like that rather than getting the coordinate axis. Either way it's okay. And then, well, fourth quadrant and a smart trig class, cosine and secant are positive, or else everything else negative. We have the complete triangle, so we can answer everything here. Let's see, can I show them in the same viewing window? Yeah, okay, I have it here. Sine is opposite of hypotenuse, but this thing is negative. Cosine 5/7, tangent opposite over adjacent, or vertical over horizontal, negative square root of 24 over 5, and so on and so forth. So my personal favorite way is to do this. Get a quadrant and draw the triangle on the quadrant. When you do that, make sure the angle in question is at the origin and the right angle is at the x-axis. Now let me show you the second method. Determine the quadrant and figure out the sine. A smart trig class, and this time, see, cosine is positive, tangent is negative. Alright, so it's on the fourth quadrant. In the fourth quadrant, cosine and secant are positive, all the others are negative. Alright, we get the sine. And then, now completely forget about pluses and minuses, and then draw a triangle in the standard position. Forget about coordinate axis. And determine the missing side. 5, 7, and then by Pythagorean, this is square root of 24. Alright? Alright. We can get the trig ratios. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. You get all those numbers, and then you can apply the signs separately. You already figured out the sign, right? And that's how you get these kind of conclusions. Okay, now everything is in the same viewing window. Or some people may prefer to draw the triangle first and then get the missing side by Pythagorean, and then figure out the quadrants and the signs later. So step 1 and step 2 here are interchangeable. Either step 1 first or step 2 first, it doesn't matter. Now, the first solution, which I prefer as a matter of fact, based upon the first method, you have to get the quadrant first so that you can draw the triangle on that quadrant. And then after that, you figure out the missing side using Pythagorean. Do you have time for one more? Okay, all right. Time for one more, but not enough time to use both methods. So this time, let's use the first method only. Cosecant is 9/4. Secant is negative. Cosecant is 9/4. So sine is 4/9, positive. And secant is negative, so cosine is negative. So determine the quadrant. Sine is positive and cosine is negative. Alright? Cosecant is positive, so sine is positive. Secant is negative, so cosine is negative. A smart trick class, what is it? It's S here this time. Sine is positive. So it's the second quadrant. You can draw a triangle on the second quadrant like this. So sine is 4/9, opposite of hypotenuse, or vertical over radius. And then what's the horizontal? What's x? We can figure it out using Pythagorean, and x value is apparently negative here. Okay, all right, let's figure it out. Oh, repetition of the same picture. Okay, all right. Pythagorean computation, we have negative of square root of 65. If you want just length, square root of 65, actually you can put it here. And the second quadrant, x is going negative, you can figure it out. Or getting the x value as negative because it's going to the left, and then getting the point x comma y, either way it'll work. Me, I prefer to draw the triangle and label those here rather than using the coordinate axis. So I don't care too much about this. Just get this and label it. All right. Now let's answer the question. And x is negative, negative square root of 65, going to the left. So sine is positive, 4/9, cosecant 9/4. Everything else is negative. A smart trick class. That completes the problem. If you want to use the second method, that's fine. In that case, you can completely disregard the quadrant and draw the picture and get all those labels done. Find the missing side using Pythagorean, get everything done, and then figure out pluses or minuses as completely separate place. A smart trick class again. Okay, so much for section 1, and let's meet again in section 2 in a separate video.